All right, ladies and gentlemen, we're going to continue with Module 4 notes today. Please make sure your name and number are up at the top. For these Module 4 notes, we're going to look at Lesson 15, 4-15, multiplying two fractions. This is going to be pretty similar to the fraction multiplication we've done recently. I'm going to spend a little more time talking about cross-canceling today. Cross-canceling. XV, 10 with 5 more is our Roman numeral. And then we'll dive right into it. Now, aside from the cross-canceling itself, not a ton of vocabulary. Cross-canceling, it's best if I just demonstrate. So, here's our process. Step 1. Step 1. Write the expression horizontally. This is different than adding and subtracting fractions. This is different than adding and subtracting anything else. This is one of the few times where writing the expression horizontally will help you. Horizontally. There we go. Write the expression horizontally. So if I ask you what 4/5, let's put a hyphen in there, 4/5 of 3/10 would be. First of all, I'm thinking, well, fraction of, that means I will be multiplying. So I'm multiplying 4/5 times 3/10. 4/5 of means times 4/5 of 3/10. Okay? So 4/5 of 3/10 is the same as 4/5 times 3/10. Now, this is where we talk about cross-canceling. Think about it as step 1.5. Okay? I'm going to put a big star here because it's a big if. It won't always work. If you can. Cross cancel. Now this is actually, you know what? I'm going to capitalize that. Let's make it nice and fancy. Cross cancel. This is going to be mostly for the folks who liked to do their division first when we were multiplying a fraction times a whole number, because this is essentially that process just for two fractions. Okay. Now I'm going to rewrite the fractions I'm working with. 4/5 times 3/10. I'm going to give myself a little more space to work with. You won't always have to do this, but at least for the notes, I want you to have some room to breathe. Let's see. Okay. I'm going to zoom in on this part also. There we go. Now you're going to start by using the multiplication symbol to guide you. You're looking at the diagonals. You're looking at the numbers that are diagonally across from each other. So 5 and 3. And I'm going to ask myself, can we divide by a common factor? Is there something that will go into both of those numbers? Can we divide by a common factor? Now, when we're looking at 5 and 3, I can kind of go through some of my prime numbers. Can I divide them both by 2? No. Can I divide them both by 3? No. Well, once I pass that, then we're done. 3 right here. I'm not going to be able to divide by anything bigger. So the answer here is no. We're not going to do anything else with them, and that's okay. Again, sometimes that's what happens. Now, if I look at my other diagonals, I ask the exact same question. Can we divide by a common factor? This time I get a slightly different answer. Hopefully you're looking at 4 and 10, realizing they're both even numbers. That means if nothing else, I could divide them both by 2. So yes, for this second set of diagonals, yes, we can go through and cross-cancel. Now, We'll talk later about finding the greatest common factor and things like that, but really we're just going to go with the number I already said. Divide by 2. Divide by 2. 4 divided by 2, well, that's going to make 2. So now instead of 4 over 5, 4 divided by 2 gives me 2 over 5. 10 divided by 2 will become 5. So instead of 3 over 10, now it's 3 over 5. These fractions are not equivalent. There's kind of a lengthy algebraic reason why this works. Don't worry about that right now. We can talk about it during class. But you're looking at the diagonals, asking, can we divide by a common factor? And if the answer is yes, then do it. You are simplifying as you go. All right, now step 2 is pretty much just to finish. We're going to do what we did in previous lessons. We are going to, sorry, let me make sure I write my step 2. Step 2, we are going to multiply straight across. Multiply straight across. This is why it's so important to make sure that you're writing everything horizontally. Okay, multiply straight across. Numerator times numerator. Denominator times denominator. Numerator times numerator, denominator times denominator. Now remember, we have new numbers. We did some cross-canceling. So now we've got some new numbers to work with. We originally had 4/5, but we changed the 4 to a 2. We originally had 3/10, but we changed the 10 to a 5. Okay. 2 times 3 is equal to 6. 5 times 5 is 25. And I'm sorry, folks. I know. You love when I erase stuff. But let's make sure we have the visual. Let's write 2 times 3. Let's write 5 times 5. Then we can put our final 6/25. Okay. Now if I had skipped over, if I had just avoided cross-canceling, 4 times 3 is 12, 5 times 10 is 50. I could have done 12/50ths and then simplified. But 12/50ths is kind of a weird-looking fraction. I don't know. Cross-canceling, simplifying while we work is usually easier. All right, for step 3, let's go ahead and simplify if possible. And again, if you did your cross-canceling correctly, you won't need to. Always a good idea to check. Always a good idea to check. Simplify if possible, and record. Okay. So 4 over 5 times 3 over 10. Again, we cross-canceled. We already know it's 6/25. But real fast, I'll show you. 4 times 3, again, is 12 over 50. Simplify, in this case, it is possible, which means it's necessary. 12 divided by 2 is 6. 50 divided by 2 is 25. We had that already. 6/25 is our answer for this particular example. Now, a lot of 5th graders are resistant to cross-canceling. They don't necessarily like it, but I'm really going to push us to practice because it makes things a lot easier, especially as the numbers get bigger and more complex. We're coming up on the 10-minute mark, so let's do just a small handful of examples, and then I'll let you go for the time being. I will give you more fun practice in class. Let's do 1/2 of 2/5. What would be 1/2 times 1/2 times 2/5? 1/2 times 2/5. Start by cross-canceling. 2 and 2, well, it's always nice when they're the same, because if they're exactly the same, like 2 and 2, you just divide by 2. You divide by whatever it is. If they're the same, just cross them out and turn them into 1. Cross them out and turn it into 1. 2 divided by 2, 2 divided by 2. Easy. Now, unfortunately, 1 and 5 won't cross-cancel. There's nothing that'll go into both, but it's not a big deal. We can just go ahead and multiply straight across. 1 times 1, 1 times 5, and your answer will be 1/5. Now, I can check to see if it needs to be simplified, but I'll tell you a fraction that has a 1 on the top, it's already in simplest form. It's a unit fraction. You can't really get any simpler than that. All right, let's do another one. Let's do 5/6 times 3/10, 3/10. Okay. Start with this diagonal right here. It really doesn't matter which one you start with. It's kind of the way I usually go, but it doesn't matter. 6 and 3. Can't divide them both by 2, but I can divide them both by 3. So I will. 3 divided by 3 is 1. 6 divided by 3 is 2. Nice. Check the other ones, and lo and behold, I can do this one too. Nice. 5 and 10 can both be divided by 5. So, cross out the 5. 5 divided by 5 is 1. 10 divided by 5 is 2. So now, where we had 5/6 times 3/10, now we have 1/2 times 1/2. 1 times 1 across the numerators, 2 times 2 across the denominators, making our final answer 1/4. Another unit fraction. Nice. We'll do one more together, then I'll give you some examples in class. As always, just, again, if you have questions, make sure you bring them. Let's say I have a whole number. 14 times 3/7. Now, we've done a lot of these fraction times whole number, and I think hopefully by now you feel pretty comfortable solving those. But let's pretend we don't know where to start, so we're going to use the same methods as up here. Now, the first thing I've got to do is turn my whole number into a fraction. To do that, I just put it over 1. Any whole number over 1 is going to be an improper fraction. That's it. That's all I got to do. We'll multiply that times 3/7. I'll check the 1 and the 3, but yeah, nothing's happening there. I can divide them both by 1, but that doesn't change anything. 14 and 7, however, are part of a fact family. I know that 14 divided by 7 will work out evenly, so I'll divide both of them by 7. 14 divided by 7 is 2. 7 divided by 7 is 1. Multiply across, numerator times numerator, denominator times denominator. I get 6/1, which, thinking back to this, 6/1, 6 divided by 1, well, 6 divided by 1 is 6. All right. I know I gave the speech earlier. If you have any questions or comments, bring them to class. We'll go over them. But for now, we are finished. Thank you, ladies and gentlemen. I'll see you next time.